My name is Chalavit Natti. Today I would like to present our work titled Model-Based Gait Recognition using Graph Neural Network. This work has been conducted together with Dr. Narathiya Kamsevanan, and we are from Skeletal International Institute of Technology, Thammasat University, Thailand. In this work, we're focusing on developing a biometrics technique that be able to detect the characteristics of human being. Biometric is a study for identifying people based on their distinctive characteristics. And nowadays, we have several types of biometrics, such as fingerprint, retina, face, or palm weight. Gait, or the movement of human body, can be used as a biometrics. Gait recognition is a biometric technique that uses dimensions and movements of the body to identify a person. The advantage of using gait is that gait can be used to identify people non-invasively. We can observe subjects from a far distance, and this is also useful for anti-terrorism. There are two types of gait recognition technologies. The first type is called model-free or apparent-based method. This is the technique that gait features are extracted directly from images when we capture image of walking person from video camera. Another technique is called model-based method. This is the technique that we try to recognize the locations or the human structures by identifying the structural data and use this skeletal or structural data in order to identify human. This work, we focus on developing a new model-based method. The basic characteristics of gait recognition system is that you are given a walk, then from each walk, we create a technique to extract gait features. Then each user may have different features. From these features, we use a machine learning algorithms to create human identification models from the collected features. From this human identification model, when we given an unknown walk, feeding to this model, the models will return a user that can be identified or user with the closest gait features to the features represented by the model. The objectives of this work is to create a human identification system that can not only accurately identify people in real time, but also we want to collect gait information of a person without their awareness. Here we focus on gait recognition technique that we apply to freestyle walk, not just fixed direction walk, because freestyle walk is more natural to happen in real world setting. At this stage of our research, instead of using silhouette or image of subject body, we use skeletal data extracted from Microsoft Kinect and Microsoft Kinect SDK as the input data to the model. And this is how Microsoft Kinect looks like. Microsoft Kinect can be used to collect gait information from user. It is a kind of motion sensing device that consists of RGB cameras, multiples of them, as well as microphone. And based on the capture image, Microsoft Kinect SDK can detect the three-dimensional coordinate of the 20 joints of the human body. And this skeleton tagging system help increase the amounts of research in the area of model-based gait recognition, because from the image, we can extract the location of the joint automatically. Then we use the location of the joint to identify a person. And this work, as mentioned before, focus on freestyle walking. Here, it means that the coordinate of the walk cannot be directly used. We need mathematical formula to transform the data to a meaningful one. And we have been proposed a coordinate system that is called center of body or COB coordinate system. This is coordinate system that use the center of body joint, which are the hip center, hip left, hip right, and the spine joint, to be the axis of the coordinate system. And this COB coordinate, we try to rotate the body so that the observation angle are the same in every frame where we detect the human body inside. And this help tackle the viewpoint issue even in the freestyle walk scenario. Then in this work, we're focusing on using graph neural network as a machine learning tool to classify human subject. Unlike traditional neural network that mostly working on Euclidean data such as images or text, a graph neural network handle non-Euclidean data such as social network or molecular structures that can be represented as two sets, the set of vertices and set of edges. Here, based on the basics of the graph, a graph consists of two sets that are a set of vertices V and a set of edges E. Each edge in the set connect two vertices. And graph can be directed or undirected or weighted or unweighted depending on type of the graph. Then in the graph neural network, the ideas of the graph neural network is to try to create a network that try to utilize the features of each node as well as the relationship between nodes by using node features and edge feature to represent that. The basic idea behind graph neural network is to use the message passing concept. We consider each node containing some message, and message is aggregated from neighboring node through the edge. And by repeatedly combining or aggregating information from neighboring nodes several times, we can create a representation vector for each node. And this can be done by passing the information through a fixed numbers of iteration or layers. This is an example of how the node representation can be conducted. Given the representations of each node, the information is passing from neighboring node to the other node, and then the combinations of the information are passing to a nonlinear activation function to be used as a representation of node V. And we have several types of graph neural network. Graph convolutional network generalize the convolution operation of graph data by aggregating features using the adjacency matrix with self loop with the degree matrix, as well as have the trainable weight matrix to transform the aggregated information and passing through activation function to be the representing vector or embedding vector of each node. Another ideas of using graph neural network is the graph attention network. This is the graph neural network or a graph neural network layer that compute attention coefficient for each edge that allow network to focus more on relevant part of the graph. And this attention mechanism is similar to the attention mechanisms that used in transformers in the natural language processing. For our proposed method, in this work, we propose a novel method to identify human subject using graph neural network. And similar to previous work, we focus more on not even the freestyle walk, but we try to handle very short sequence of walk. In this case, we define a sequence of walk as a walking period of 2 seconds. This is because the capability or the ability to correctly identify human from very short sequence will enhance the benefit of the proposed method in terms of surveillance, in terms of detecting human with very short period of time. In order to achieve the models that handle very short walking sequence, we need to provide a way to represent walking sequence. Here, we create a data set composing of very short walking sequence where each sequence composed of 40 frames. Therefore, each walking sequence is represented by a sequence of frame fi, where I is starting from 1 to 40. Each frame should capture a posture of the human subject. And as I explained before, that each frame is represented by 20 body joints as a skeletal data. Each joint is a three-dimensional coordinate showing the location of the joint. Therefore, we can simply represent a frame as a matrix of 20 rows, 3 columns. Each row represents each joint. For example, the first row represents hip center, the second row represents spine, and the last row represents foot right. Each row has 3 columns that are the 3D coordinate X, Y, and Z. Then, most of the existing work represent frames as vectors or matrix and try to apply traditional convolutional operators in order to transform or extract features from this frame. But traditional convolution cannot be used efficiently with these kinds of data because of the skeletal data has more complicated structures. Graph should represent the relationship between joint and using combining features among neighboring nodes in more proper way. So in this work, we use a graph to represent each frame. So from the left-hand side, where we have a matrix by 20 rows, 3 columns, represent a frame, we transform this matrix into a graph where each node is a joint represented by 3 features, their location, X, Y, and Z. And they are connected by edge that represent the body structure of a human. Moreover, from another previous works of our group, we found that human subjects can be correctly identified from their unique posture and small movement. Therefore, instead of using only each one frame for the classification or using the entire 40 frame for classification, we split each walk into multiple sliding windows. Each window represents a sequence of m frame, consecutive m frame, where m is an all positive integer such as 3. So when m equals to 3, we can create 38 sliding windows from window 1 to window 38. Then from 3 consecutive frames, we create a graph. This graph composed of 2 types of edges. The edges that link within the same frame based on the body structures as shown in this slide as the solid dark black line, and the edge that link to the same joint of the adjacent frame. These are represented by the dotted line with different color. And by doing this, we can represent each walk as a sequence of sliding window graph. So sliding window is transformed into a graph. We have 38 graph when m on the size of the sliding window is set to 3. Then we propose neural network models to identify this. So we are given a walk composing of 38 sliding window graph. We separate this graph and treat them separately. Each graph is fed into a graph neural network that I will explain in the next slide. And fed to the fully connected layer in order to predict a probability that the graph, the sliding window graph, can be identified as each human subject. And this is represented as P hat I. All of these P hat I are aggregated, and we use all of these information combined together in order to predict Y hat, which is the final prediction. For the details of the proposed neural network, we use several graph convolution layers and passing through the pooling layer in order to combine a group of nodes, a cluster of nodes together to form a smaller graph and apply graph convolution layer again before we combine using another pooling layer to combine them into one vector. The vectors that we get from each sliding window graph is passing to fully connected layer, multiples of them, and the output layers of this network using softmax activation function in order to predict a probability vector, where each element of this probability vector represents probability that the feeding sliding window graph is identified as each human subject. Suppose we have few human subjects in the database. We have the probability vector composed of P hat 1, P hat 2 until P hat U. Then we combine or aggregate all the probability vectors from each sliding window graph, and the highest aggregated probability value is used as the predicted output for the entire walk. And right now, we use additions as the default aggregation operation. For the current progress, we are now conducting experiment on multiple datasets, and the preliminary results are promising with the above 90% accuracy. And we hope that we can finish this experiment and we can show the results soon. And thank you for your attention.